methanol as a fuel. To control the GHG, the initial strategy led to the development of short-term measures, including the Energy Efficiency Existing Ship Index, the Enhanced Ship Energy Efficiency Management Plan, and the Carbon Intensity Indicator. Methanol supports compliance towards the IMO's 2030 Carbon Emission Reduction Target, IGF code, International Code of Safety for Ship-Using Gases of Other Low Flash Point Fuels, MSC Circular 1621, Interim Guidelines for the Safety of Ships Using Methyl or Ethyl Alcohol as a Fuel. Methanol? What is it? Methanol, also called methyl alcohol, is a lighter than water, volatile, colorless, and flammable liquid alcohol. Its name comes from its early derivation from methanol. Each methanol molecule has one carbon atom and 4 hydrogen atoms, and it is the simplest alcohol. It is a liquid at ambient temperatures and pressure and can be stored in modified fuel tanks on existing vessels. There is little sulfur content in the fuel, resulting in no sulfur oxides forming during combustion. Particulate matter and soot emissions are also low, highly miscible, so dissolve in seawater in case of spill. Methanol evaporative vapors may be heavier than air, causing them to spread along the ground and collect and stay in poorly ventilated, low-lying, or confined areas, such as engine room bilge areas. The 3 main drawbacks to its use are its 1. Toxicity, 2. Its low energy density, with about 225 gram, providing the same amount of energy when combusted as 100 of gas oil. An engine will need approximately 2.4 times the amount of methanol as diesel for the same fuel energy density, an indication of the increased volume of methanol storage needed to achieve the same amount of energy when making a comparison to existing propulsion. 3. Low flash point, contributing to increased fire and explosion hazards. Operation. Methanol combustion formula. 1 of methanol creates 1.375 CO2. Ship owners are recognizing that methanol provides them with flexibility in introducing a low pollution, lower carbon fuel, which is closest to a drop, available in the market. This means lower upfront CAPEX and OPEX costs compared with the current fuel choices. Methanol has less energy density compared to current diesel and fuel oils at a ratio of about 1:2.25. Therefore, on a ton-by-ton basis, a vessel would require nearly 2.5 times more methanol as fuel oil for a specific consumption. As methanol is a liquid fuel at ambient temperature and pressure, it requires minimal fuel tank specifications, but safety and health arrangements remain important. Biomethanol. Biomethanol is produced from lignocellulosic feedstocks, biomass such as agricultural waste and byproducts. The biomass undergoes a gasification or reformation process to produce syngas, which is a mixture of carbon monoxide and hydrogen gas. The syngas is cleaned to remove impurities and then subjected to methanol synthesis. This involves a catalytic reaction where the carbon monoxide and hydrogen gas react to form methanol. Methanol with DAC. Methanol is produced from carbon dioxide, extracted from ambient air using direct air capture, DOC, and hydrogen gas is produced using renewable energy. Hydrogen gas is produced using renewable energy to separate the hydrogen from water through electrolysis. The carbon dioxide and hydrogen gas are then combined through methanol synthesis, which is a catalytic reaction, to form methanol. Dual-fuel engines allow ships to be operated on either long or conventional liquid marine fuels, including LFO, OFO, or liquid biofuel. Using long instantly and drastically reduces CEO, NOx, SOx, and particulate matter emissions. The switch between fuels can be made seamlessly without loss of power or speed. Such fuel flexibility enables compliance with emission regulations in controlled areas, while giving operators the option of determining the fuel according to cost and availability. CH308. Methanol offers a host of benefits that make it an attractive choice for powering ships. Reduced emissions. Methanol combustion emits fewer pollutants, including sulfur oxides and nitrogen oxides, compared to traditional marine fuels. This significantly improves air quality and reduces the industry's environmental impact. Energy efficiency. Methanol engines are highly efficient, translating into lower fuel consumption and operational costs for ship owners. Renewable potential. Methanol can be produced from renewable sources such as biomass and carbon capture technology, making it a key player in sustainable shipping. Infrastructure compatibility. Methanol can utilize existing infrastructure, which means it can be adopted without major overhauls of ports and refueling stations.